We often talk about great minds, scientists who solved mysteries that had baffled everyone for decades. People who saw patterns nobody else could, and answers nobody had ever asked for. But being brilliant alone doesn't make someone a great explainer. Richard Feynman, the American physicist, famous for pioneering the field of quantum electrodynamics, while famously playing the bongos at a strip club, was one of the 20th century's greatest explainers. That is, he could take ideas that seemed almost impossible to grasp, ideas that made even the smartest people's heads spin, and make them clear, elegant, and deeply understandable. Feynman's life was full of paradoxes, the serious and the playful, the profound and the humorous, the genius and the mischievous. He could win a Nobel Prize in physics, invent a revolutionary diagram to visualize the subatomic world, and still spend hours pranking colleagues at Los Alamos, painting, or studying obscure cultures. Yet everything he did shared one core principle: clarity through curiosity. Richard Phillips Feynman was born on May 11, 1918, in Far Rockaway, New York. His father, Melville Feynman, wasn't a physicist, but he had an almost religious respect for the laws of nature. He didn't just tell Richard that the world worked according to principles. He taught him how to think about it. From an early age, Richard learned to question, to wonder, to analyze. Even as a child, Feynman showed an insatiable curiosity. He would dismantle radios to see how they worked, invent tiny experiments in his room, and find joy in solving problems simply for the thrill of understanding. He was mischievous, playful, and highly intelligent, but not the stereotypical child prodigy. His genius wasn't obvious to the outside world. It was hidden in his questions, his experiments, his endless desire to figure things out. One of his first lessons in clarity came from his father. Melville would ask young Richard why things happened and insist that he explain them in simple terms. The rule was, if you can't explain it to someone else, you don't truly understand it. This principle would guide Feynman's life. Simplicity and explanation were more important than memorizing formulas or impressing others. In 1935, Feynman entered MIT. He wasn't there because he wanted the typical college experience, me. He was hungry to understand the universe at its deepest level. While other students were learning classical physics and following prescribed courses, Feynman wanted to study the strange, counterintuitive behavior of subatomic particles, fields that weren't yet part of formal curricula. Feynman devoured every book he could find, skipping over the irrelevant and chasing the new, the unexplored, the exciting. He turned math into a playground, not just a tool. Numbers and equations weren't chores, they were toys, puzzles, and friends. By the time he graduated, he had a profound command of theoretical physics, the language that allows humans to predict and understand natural phenomena. His mathematical skill and insight earned him a place at Princeton for his PhD. This was no small feat. Feynman was Jewish, and in the 1930s, many colleges in the U.S. had informal quotas limiting Jewish students. Yet, Feynman's abilities spoke for themselves. Even before graduation, he was offered a position on the Manhattan Project, the secret government program developing the first atomic bomb. His role: calculating the magnitude of a nuclear explosion. He would be working alongside some of the greatest physicists of all time, including Einstein and Wolfgang Pauli. But even in this serious and highly secure environment, Feynman's character shone through playful, curious, irreverent, and endlessly tenacious. He pranked his colleagues at Los Alamos, picking locks, leaving cryptic notes, and testing security. Yet this mischievousness was inseparable from his genius. Feynman's relentless curiosity and willingness to challenge assumptions made him both annoying and indispensable. He wasn't looking for approval, he was looking for truth, and he would find it by any means necessary. At Los Alamos, Feynman encountered the very best and brightest minds, but he also faced the enormous pressure of building the world's first atomic bomb. It was a time of unprecedented stress, secrecy, and moral complexity. Yet Feynman approached it with the same playful clarity he had always used. He questioned assumptions, simplified problems, and sought intuitive understanding rather than rote memorization. He quickly realized that working alongside geniuses didn't mean blindly accepting authority. If he disagreed with a method, a calculation, or a principle, even with a luminary like Niels Bohr, he spoke up. Feynman understood that explanation mattered more than prestige. He didn't just calculate, he clarified. What set Feynman apart from all the other brilliant scientists was a combination of tenacity and boundless curiosity. He wasn't satisfied with just knowing the answers. He wanted to understand why those answers were true. He wanted to see the world in its most fundamental terms, and then to explain it clearly to others. Even as the Manhattan Project demanded focus and secrecy, Feynman continued to experiment mentally and physically. He played with ideas the way others played games. He treated every problem as a puzzle to be solved elegantly. And this habit, this constant questioning and explaining, would define him for the rest of his life. After the war, Feynman turned to one of the hardest problems in physics: quantum electrodynamics, the theory describing how light and matter interact. At the time, QED was only partially understood. Equations existed, but they were tangled, cumbersome, and nearly impossible to calculate. Physicists struggled to predict how electrons and photons behaved with certainty. For most, it was a nightmare, a labyrinth of probabilities, infinite possibilities, and abstract math. But Feynman approached it like he had approached every problem in his life, playfully, curiously, and with a commitment to clarity above all else. He began to create what would become Feynman diagrams, simple sketches that represented incredibly complex interactions. Each diagram showed particles exchanging photons, moving through space and time, transforming in ways that equations alone could barely describe. It was a language that made the incomprehensible visible and understandable. Through these diagrams, Feynman did something no one else had. He took chaos and made it clear, turning infinite possibilities into something the human mind could grasp. And this, more than anything, cemented his reputation as the great explainer. By the late 1940s, Feynman was on the brink of reshaping physics forever. He had the tools, the curiosity, and the mind to illuminate the subatomic world in ways no one had imagined. But this was just the beginning. His diagrams, his teaching philosophy, and his playful genius were about to change not only physics, but how the world understood explanation itself. By the late 1940s, Richard Feynman was poised to transform physics in ways few could imagine. The world of subatomic particles, electrons, photons, and the invisible forces governing them was chaotic, tangled, and nearly impossible to calculate. For most physicists, predicting the behavior of these particles was like trying to predict every drop of water in a raging river. But Feynman had a secret weapon, a mind that saw patterns, probabilities, and elegance where others saw confusion. Quantum electrodynamics, or QED, is the theory that describes how light interacts with matter at the smallest scales. It's the foundation of how electrons, photons, and other fundamental particles behave. But in the 1940s, this theory was incomplete and chaotic. Calculations often produced infinities, predictions that made no sense, or math so convoluted that even brilliant physicists were stuck. Feynman approached the problem differently. He didn't see equations as mere symbols to be manipulated. He saw them as stories of particles moving, colliding, exchanging energy, and interacting with the universe itself. He imagined electrons playing games with photons, hopping from one state to another, sometimes colliding, sometimes vanishing momentarily. Every action had a probability, a chance of occurring, but the number of possibilities was overwhelming. Calculating them with traditional methods was virtually impossible. To simplify this chaos, Feynman created what would become one of the most iconic tools in physics: Feynman diagrams. Imagine this. Instead of struggling with thousands of lines of equations, Feynman drew a simple picture. Two electrons, for instance, moving through space, exchanging a photon, then moving off in different directions. In this one image, he captured the complexity of interactions that had previously been nearly impossible to track. But these weren't just illustrations. Each line, each vertex, each arrow represented real mathematical relationships. Feynman diagrams allowed physicists to see probabilities, interactions, and the timing of events all at once. They turned an abstract mathematical nightmare into something intuitively graspable. Through these diagrams, Feynman gave scientists a new lens, a way to predict, calculate, and understand the behavior of the microscopic world. What once seemed impenetrable became elegantly manageable. Feynman's work wasn't just clever, it was transformative. His approach to QED, combined with independent contributions from Julian Schwinger and Itaro Tomonaga, resolved long-standing issues in theoretical physics. In 1965, Feynman, Schwinger, and Tomonaga were awarded the Nobel Prize in Physics for their work in quantum electrodynamics. But the diagrams themselves became far more than a tool. They became a language. They allowed generations of physicists to communicate, calculate, and explore without getting lost in endless formulas. Feynman had not only solved a problem, he had changed how humans could think about the invisible world. Even after revolutionizing QED, Feynman's curiosity never slowed. He turned to quantum computing, nanotechnology, and even quantum gravity. Every new problem was approached with the same mindset: clarity, simplicity, and playful exploration. Feynman often emphasized that true understanding wasn't memorization, it was being able to explain an idea simply. He believed that if you couldn't teach it, you didn't truly understand it, and this principle applied whether he was explaining electrons, the behavior of light, or the fundamentals of the universe. Feynman wasn't just a physicist, he was a teacher, and not just any teacher, but one who could make the abstract vivid and the complex simple. His lectures, books, and stories have inspired millions, showing that science isn't about memorizing formulas. It's about seeing, understanding, and explaining. He turned classrooms into laboratories of thought. Students weren't there to passively absorb, they were there to think, question, and reason. Feynman used everyday analogies, humor, and visual storytelling to transform abstract equations into intuitive concepts. One of his most famous teaching methods was the Feynman Technique: learn something deeply. then explain it in simple words. If you get stuck, you found the gap in your understanding. This wasn't just a learning tool. It was a way to think clearly about the universe. Feynman loved analogies. To explain quantum probabilities, he compared them to a game of checkers, but with infinite boards. Imagine predicting the moves of each piece, not just on one board, but across countless boards simultaneously. This is how electrons interact in infinite possibilities, branching paths, and subtle interactions that determine outcomes. Through diagrams and probabilities, Feynman made the impossible manageable. He gave physicists tools to see the unseen and predict the unpredictable. Feynman didn't work in isolation. He collaborated, debated, and sometimes clashed with the greatest minds of his era. Einstein, Bohr, and Pauli were all contemporaries. Yet Feynman's fearless curiosity set him apart. He wasn't intimidated by authority, prestige, or convention. If he disagreed, he spoke up. If a problem intrigued him, he pursued it relentlessly. His personality was as memorable as his work. He played the bongos, painted, studied remote cultures, and pursued hobbies that seemed absurd but reflected the same playful curiosity he brought to science. Feynman's diagrams weren't just theoretical exercises, they had real-world impact. They helped design experiments, understand fundamental forces, and even influenced emerging technologies like quantum computing. He showed that clarity of thought isn't abstract. It's powerful, practical, and transformative. Feynman once said, "There's no miracle. People, it just happens they got interested in this thing, and they learned all this stuff. There's just people." That was the essence of his approach: curiosity, clarity, and persistent effort, not innate magic. By the end of the 1960s, Feynman had reshaped not just physics, but the way science was communicated. He had proven that complexity could be tamed by clarity, that the universe could be explained, understood, and even enjoyed. But the story wasn't over. Beyond the lab, Feynman's life would continue to inspire with adventures, lessons in teaching, and bold demonstrations of curiosity applied to the real world. By the 1970s and 1980s, Richard Feynman had already transformed physics, pedagogy, and the way the world approached understanding itself. Yet his story wasn't just about equations or diagrams. It was about curiosity, audacity, humor, and a relentless drive to explain and explore. Feynman was, in every sense, unconventional. While many scientists were trapped in the rigid formality of academia, Feynman approached life as an experiment. He painted, played the bongos in bars, studied foreign cultures, and collected the kinds of experiences that most people dismissed as irrelevant. To him, everything was data, everything was a story, everything was a chance to see patterns and connections. Whether solving a physics problem or learning how to play a new instrument, he brought the same level of playful curiosity. Feynman's greatest gift to humanity might not have been his research alone, but his ability to teach profoundly. His lectures, later compiled into the Feynman Lectures on Physics, are considered some of the most effective science education ever created. He didn't just present formulas, he wove narratives. He drew pictures. He asked questions that forced students to think, not memorize. He believed deeply in the power of explanation. If you want to master something, teach it. If you can't explain it simply, you don't understand it. Feynman's teaching style was revolutionary because it respected the learner. He made space for curiosity, for confusion, for mistakes. He never shamed students for not knowing. He guided them to clarity and insight. Feynman's curiosity extended beyond physics. He explored mathematics, biology, music, art, and even remote cultures. He famously tried to visit Tuva, a remote region in Asia, just to study throat singing. He wrote in letters, studied maps, negotiated with governments, all in pursuit of understanding something that fascinated him. This curiosity was not mere hobbyism. It was a philosophy of life. Feynman believed that learning and exploration were ends in themselves. To understand the world was to enrich one's life, not just one's resume. In 1986, the Space Shuttle Challenger exploded shortly after launch. Feynman was appointed to the investigation committee. Unlike others, he refused to accept vague explanations. During a televised hearing, he performed a now famous experiment. He placed an O-ring, the rubber seal from the shuttle's booster, into ice water. The ring lost its elasticity. In that simple demonstration, Feynman revealed the true cause of the disaster. Cold temperature compromised the O-ring's reliability. This moment showcased his brilliance, clarity, and integrity. He didn't rely on authority. He didn't obscure his findings with jargon. He showed the truth plainly, simply, and compellingly. Feynman's philosophy was consistent across all his pursuits. He valued clarity over pretense, curiosity over conformity, and understanding over memorization. He once said, "There's no miracle, people. It just happens they got interested in this thing, and they learned all this stuff. There's just people." Feynman reminded us that genius is accessible to anyone willing to cultivate curiosity and clarity. It isn't innate. It isn't reserved for a select few. It emerges from sustained effort, playful exploration, and the courage to ask questions and simplify answers. Richard Feynman left behind a legacy that goes far beyond physics. He showed the world that explanation matters. True understanding is demonstrated by the ability to teach clearly. Curiosity is a guiding principle. Pursue what fascinates you relentlessly. Playfulness fuels creativity. Science doesn't have to be rigid or dry. Simplicity is power. Complexity should never obscure insight. Through his books, lectures, interviews, and life story, Feynman continues to inspire generations to think critically, question boldly, and explain clearly. Despite all his achievements, Feynman was remarkably human. He struggled with loss, battled cancer, and faced challenges that tested his resilience. Yet through it all, he maintained a zest for life. His humor, irreverence, and audacity remind us that even the most brilliant minds are human, curious, flawed, and playful. He once quipped on the topic of death, "I'd hate to die twice. It is so boring." This simple statement captures the essence of his philosophy: approach life with curiosity, joy, and an unending desire to explore. Richard Feynman's greatness wasn't only in the problems he solved. It was in the way he shared understanding, made the complex approachable, and inspired others to see the world clearly. He wasn't just a physicist, he was a communicator, a teacher, a mentor, and a lifelong student of reality itself. From his diagrams to his lectures, from Manhattan to Challenger, Feynman demonstrated that clarity and curiosity are the hallmarks of genius. He showed that learning isn't about memorizing facts. It's about transforming information into understanding and understanding into action. Feynman's life teaches us that anyone, anywhere, can become a great explainer. All it takes is curiosity, persistence, and the courage to ask why, and then explain it simply. Thank you for watching this journey through the life of Richard Feynman, becoming the great explainer. If you found this video insightful, don't forget to like and subscribe to the channel. Hit the notification bell so you never miss another story of genius, curiosity, and learning the Feynman way. Remember, those who teach, learn. Those who simplify, master. And those who practice every day become unstoppable.